You're on the YouTube page. Is it showing that we are live? You should be seeing me. Are you seeing me? You're seeing me, right? Is the network clear? Let me know. Okay, can you see me? We are live. We are live. You can see me, right? I'll be using my AirPods so I can also communicate with you guys without disturbing the stream. So you can see me, you can hear me, and you can see me. Can you see the board? Can you see the board? Okay, yes. Toxic tribe. That's beautiful. So if you can hear me, drop it in the comment section. I'll be ending the WhatsApp call soon so we can focus on the class on YouTube. But if your network is bad or having any connection issues, you can also drop it in the comment section. Let me share the link on the WhatsApp group so you can join in. All right, we're live. We're live. Let me know if you can hear me and see me. All right, Peter Amadi, yes. Lenny Confident Precious, yes. Beautiful. So we are live. All right, so we are complete now. Okay, Christian Faith Glorious, beautiful. So you can also share the link to others in the group. Let me share it. So we can kick off. Okay, so where do we stop? Where do we stop? So today we'll be talking about the very first topic in JAMB called units and what? Measurement. Units and measurement. Very important topic. Very important. Units and measurements. Too light, it's too light. Make it thick. Make it this. Okay, it's showing now. All right, let's go. So the first topic we'll be covering today is what? Measurement and units. Measurements and units. So let's start the timer. If you can see the board properly and clearly, and you can hear me properly and clearly, please let me know. See the board and you can hear clearly. Measurement and units, please let me know if you can see the board properly. Let me know in the chat section. Let me know if you can see the board properly and you can hear me. Just indicate in the chat. Yes, yes, yes. A whiteboard will be faster because of your typing speed. Yes, we can hear you clearly. All clear. Use marker board. Okay, better. If you use the marker board, right, that will be better because that will be faster so we can cover more things. Okay, I think we will use the marker board. So if you use the marker board, better, better, better. I think we should use the marker board. All right. So let me set up the marker board. I'm coming. Give me 1 second. Let me use the marker board. I'm coming. So you can hear me, you can see me. We are using the marker board. We are going to use the marker board now. Let's use the marker board. That will be better. Can you see the marker board clearly? Let me know if you can see the marker board now. Can you see the marker board? If you can see the marker board, let me know. Let me know if you can see the marker board. Is it clear? You can see it, right? Okay, beautiful. And is the audio clear? Is the audio clear? If the audio is clear too, then we can proceed. Can you see me? If you can see me, let me know. Okay. Okay. So check if you can see me. You can see me. Can you see the board? Measurements and units. Is it clear enough? It's clear enough, right? Okay, so we'll proceed. We'll proceed. You can see me very clearly. We'll proceed. Have I ended the WhatsApp call or the WhatsApp call is still on? Okay, beautiful, beautiful. So let me just take my system over there so that in case I want to communicate with you or it will be easier to communicate. Sorry, not give me 1 second so I can arrange this in table very well. All right, perfect. Okay, we are set. We are set. We are set. Beautiful. So please bring out your writing materials because we'll be covering this topic called measurement and unit. Please bring out your writing materials. Bring out your writing materials. Okay. Measurement and unit. So today we're looking at what? Measurement and unit. Measurement and unit. So let me introduce myself again. My name is Divine and you can call me the JAMB specialist. So I'll be preparing for the 2026 JAMB Physics. We'll be covering it topic by topic. So the first thing I'm going to do is to highlight the what they call course outline, what we'll be covering. So let me write out the outline. The first one, which is this topic, measurement and unit. Please take this down. So these are the topics we'll be covering in JAMB here on this channel. In case you're new here and you're not on our WhatsApp community, we'll add you after the class. I'll drop the link to the WhatsApp community and group in the description. Please, can you see me? Can you hear me? Are you seeing the board? Is it clear? Let me know. Let me know if the board is clear. Please let me know if the board is clear. If you can see the board clearly, let me know. The board should be clear so you can understand what we're about to do now. You should be able to see the board clearly, clearly. Okay. Okay, Peter said yes. Toxic type, he said I have ended it already. Okay, yes, you can see me. Thank you, thank you. You can see the board clearly, right? Measurement and unit, scalar and vector, motion, gravitational field, equilibrium of forces. So please write this down, write these topics down. We'll be covering them. So write it so I can clean the board and continue. We have work, energy, and power. So you can either write it or you take a snapshot. I'll also post it on the WhatsApp group. So please write it down. Who is calling me? This is not the time to disturb our network. Who is calling? Who is calling? Who is doing this, you know? Who is calling us? Okay, so we can proceed. I've put my phone on do not disturb. So they will not interrupt our section. So let's continue, please. Let's continue from where we stopped. Let's continue from where we stopped. All right, let's continue from where we stopped. So my phone is on do not disturb. So you will not disturb our class. Please, you don't need distractions. You need to focus on this. All right, so let's continue. If you're done, write down so I can clean and we can proceed. So measurement and units for 6. We continue to number 7. So can you see me? Can you hear me? Let's go. To number 7, we have friction. Number 8, we have simple measurements. Number 9, we have electricity. Hooke's law and Young modulus. Please, if you're here and you see me, let's go. Can you hear me? Let's proceed. Let's proceed. In case you have any challenge, you can also drop it in the group. I'll see it there. or drop it on the chat. Beautiful, beautiful. So number 10, we have measure. 11, we have liquid address. These are the topics we'll cover. This is for JAMB 2026. So we'll finish it before your exam. We'll cover all these topics. So you can take a snapshot. Either you take a snapshot or you write it down, but please build your writing material so you can write it down. If you're done, proceed so we can continue. If you're done writing, tell me, let's proceed. If you're done writing, say proceed and we'll continue. If you're done writing, just type proceed and we'll continue with the outline. Are you done writing? Let's proceed. So let's continue. So number 12, we have temperature and its measurements. Number 10. So these topics are very important. We'll cover them. We have thermal expansion. We have those. Number 15, we have from the tables. 16. So target value for the JAMB 300 plus quantity of it. Number 16, we have change of state. Okay, and write them down. Write them down. Write them down. If you're done writing, let me know so we can proceed. Are you done writing? Let me know. Christian, faithful, glorious. Are you done writing? Toxic type, dense. Are you done? Amadi, are you done writing? Let me know. Write proceed so we can proceed. Beautiful. If you're done writing, let me know so we can proceed. Then, okay, proceed. Thank you. So I can tell you that we can proceed. Let's proceed. Number 17, we have vapors. Number 18, We have structure of matter, structure of matter and kinetic theory. Number 19, we have heat transfer. And number 20, we have waves. And finally, number 21, we have propagation of sound waves. All right, so these are the 21 we'll be covering from the JAMB syllabus. So we'll start with the first topic, unit and measurement. So if you're done writing, say I am done writing in the comment section. We can start with today's topic. If you're done writing, say I am done writing in the comment section so we can proceed. If you're done writing, please indicate by saying I am done writing in the comment section so we can proceed. If you're done writing, just let me know. Say I'm done writing in the comment and we will where we are. Done writing. All right. I am done writing. Okay, beautiful. Confidence is done. Faith, glorious is done. Done. Toxic. Okay, toxic time. You're done. Beautiful, beautiful. Let's proceed to what we have for today. Units and measurements. Let's proceed for what we have today. Units and measurements. Units and measurements. So, from our previous call on WhatsApp, I said we'll be covering measurements. So take note, take note. Hope you are with your writing materials. Measurement. Measurement is comparing a quantity with a standard unit. What is measurement? Measurement is what? Comparing a quantity with standard units. Measurement is what? Comparing a quantity with a what? Standard unit. That is measurement. So let's take some examples of units. Examples of what? Standard units. So the first unit we have, can you hear me? If you're here with me, say I can hear you in the chat so I can proceed. So the first example we have is what? Length. This is the first unit we have. We also have what? Mass. We also have These are all standard units. So these are all standard units. For length, whenever we are measuring length, let's say we have a board here and we have to measure the length of this board. So let's say, for instance, the length of this board equals to what? 5. We'll not just write the length equals to 5. We have to add a standard unit for. So we have to say the length is equals to what? 5 meters. If we say just 5, then we are wrong. And length meters. And the symbol for meter is what? M. Please take note. Please take note. Secondly, we have mass. For mass is measured in what? Kilogram. Mass is measured in kilogram. Now we have a body. This is and we want to measure the mass of this body. The mass of this body, let's say the person is standing on the weighing balance. So let's say now you are taking the weight of your body or the mass of your body. After measurement, you find out you're weighing what? Let's say you're weighing 60 kg. That's the mass of the body, 60 kg. Because you're weighing, you say you're weighing 60 is wrong, but if you say you're weighing 60 kg, this is correct. So we successfully what? Compared a quantity which is 60 with what? A standard unit, the kilogram, that is mass. And for length, we've compared this is our board. We've compared the board length, which is 5 units, which is meters. So next we have what? Seconds for time. We measure time in what? Seconds. And time is what? S. If you're with your writing material, you can take this down. Please take notes. Please take notes. Take notes. Write this down, or you can take a snapshot of it. But it's better you write it down because as you're reading and you're writing, and you're also using the 3 phases of learning: reading, writing, hearing, listening. So please, measurement is comparing a quantity with a standard unit. And some examples of units are length, measured in meters, mass, which is measured in kilograms, and time, which is measured in seconds. So we did the measurement. Okay, you're done writing. For time now, let's say this is a stopwatch. And what's going on now? Two people are running. And this is time. So this time now will help us to know how many seconds it took them to what? Reach the finish line. This is our stopwatch, which will record the time. Let's say this first person took 20 seconds and this person took what? 80 seconds. So that's how we measure the time. So are you done writing? You're done writing, let me know so I can clean up. write I am in the chat box so we can proceed. Christian Faith Glorious, are you done? Confidence Precious, are you done? Let me know, let me know. Toxic, are you done? Confidence, Peter Amadi, let me know if you write it down in the comment section. Alright, so I can proceed. I'm cleaning the board. Alright, let's proceed. So next up, under measurement and units, we'll look at physical quantities. Physical what? Quantities. Physical quantities. And under the physical quantities, we'll look at what? Fundamental and basic quantities, or let's call it base. This is base quantities, and we'll look at derived quantities. So fundamental quantities, these are quantities that cannot be derived from others. For fundamental quantities, take note please, write this down. For fundamental quantities, fundamental quantities are quantities that cannot be derived from others. So fundamental quantities are quantities that cannot be derived from others. Previously, I asked, what are the fundamental things we need as humans to survive? Please let me know in the comment section. Type it down. The essential need as humans to survive. Please write it down. Let me know. Let me know. Just list one in the comment section. If you can hear me, please let me know. As humans on earth, what are the things that we cannot do without? Those important things. Important things that human cannot do without. Important things humans cannot do without. So this is my question now. What are the important things human cannot do without? Okay, someone said food, someone said air, water, correct, correct, you're all right. So for that, for getting it correct, let me draw a plate of food for you. Yes, this is our chicken. This is spag. This is our indomie and what? Egg. And this is our spoon. And this is our cylinder. So food for instance, is very survival of humans. Very important. Humans cannot do without food. Yes. Someone said shelter, right? Shelter. So let's draw a house for that person. Let's draw a house. Let's draw a house. Let's draw a house. A very sharp house. A very sharp house. This house should be very fine. And this is the garden of the house. Let's see here. Here. And this is someone going to his house with a child. So shelter, very important. Shelter, very, very important. You see, so humans cannot do without shelter. Food, our food is in the house. Our food is in the house. They cannot do without shelter. Yes. So these are what fundamental quantities. Just the way food and shelter is very for humans to survive. That's the way fundamental quantities, that's the base quantities, are very important for other quantities like the quantities to be what? Active. You get? In order for derived quantities to exist, fundamental quantities must be there. So if you've written this down, please let me know. I hope you're with your writing materials. Write this down. I'm done writing so I can proceed. If you're done writing, let me know so I can proceed. If you're done writing, let me know so I can proceed. Amadi Peter is done writing. Who else is done writing? Let us know. Okay, Faith Glorious, she's done writing. Who else is done writing? Please let us know. Let us know. Let us know if you're done writing. Let us know. All right. Let's see. Confidence is done writing, so we can proceed now. All right. So let's proceed. We are still under physical quantities. So let's proceed. Let's proceed. All right. So I said we are still on fundamental quantities, right? I'll list some fundamental quantities, their units and symbols. So quantities, first of all, let me write it down. Fundamental quantities. So these are some quantities. Units and symbols. So you can type in the comment section one fundamental quantity you know, one fundamental quantity you know. Please let me know one fundamental quantity you are aware of. So you can let me know the fundamental quantity you know so I can tell you the unit and the symbol. Type it in the comment section. Let's go. Let's go. Can you hear me? If you're there with me, Type the fundamental quantities. Type one of them you know, one of them you are aware of for fundamental quantities. All right, let's proceed. Time, correct. Correct. Keep typing, keep typing. Christian said time. Beautiful. We have time. Let's write it down. Time. We have time. Who else? And time, the unit for time is what? Second. And the symbol for time is called S. All right. Any other person? Any other person? Type it in the comment section. One fundamental quantity you know. All right. Let's proceed. So this is the first one. Second one, we have length. For length, it's measured in meter, and the symbol for length is what? M. Electric current. Beautiful, beautiful. Electric current. Electric current. Let's write it. Someone said electric current. Current. And for electric current, we have ampere, and the symbol for ampere is what? A. So mass. Okay, let's write down mass. Mass, and the symbol for mass is what? Kilogram. And kilogram, we have kg. We have three more, three more, three more. Who can give us one more? Temperature, we have temperature. Who else can give us one more? We have temperature measured in Kelvin, and the symbol is K. Number 6, we have amount of substance. Amount of substance. Amount of substance, which is mole, measured in mole. The unit for amount of substance is mole. Beautiful, and the symbol is mole. And finally, we have luminous intensity. Luminous intensity is measured, the SI unit is candela, measured in candela, and the symbol is what? Luminous intensity. Luminous intensity. So take this down so we can proceed. All right, take this down so we can proceed. If you're done writing, let me know in the chat box. If you're done writing, let me know. You're all correct. Peter Amadi, you're correct. Confidence, Leslie, Precious, temperature and amount of substance, you're correct. Toxic type, mass, you're correct. All right. Christian, Glorious, okay. If you're done writing, let me know you're done writing, or take a snapshot so we can proceed. Let's go, let's go. Let's go. If you're done writing, please let me know so we can proceed. All right, done writing. One more person, just type done writing. Derived quantities. All right, proceed. Okay, let's proceed. Let's proceed. Let's proceed. Let's proceed. Let's proceed. Beautiful. Okay. So next up, we have what derived quantities. You that derived quantities are quantities gotten from two or more fundamental quantities. And without the fundamental quantities, the derived cannot exist. So they are gotten from what? Fundamental quantities. Yes, they are gotten from fundamental quantities. Example, let's say speed, like I used before, I'll repeat it. Speed. So who can tell me speed? The derived quantities that we can use to get speed. What is the unit for speed? Who knows the unit for speed? Another person, what is the unit for velocity? Speed, let's check speed. The unit for speed, let's say a boy is running on a track. What is the speed I will use to get to the final point? This is the finish line. So what is the speed you need? How do we get the unit for speed? And velocity, let's say a car is moving. So this car is maintaining a constant velocity. So tell me the quantities we use to get speed for this thing. Okay, distance over time, correct. Distance over time. So speed distance over what? Time. So velocity, who can tell us for velocity? Velocity, let me know in the comment section what is the unit for velocity. Alright, let me know. Okay, velocity is what? Displacement over time. So this is for speed and this is for velocity. And if you notice, in the both of them are what? Derived quantities. The both of them are what? Derived quantities. If you notice, in both of them, we have a fundamental quantity. This is a fundamental quantity. This is a fundamental quantity. So derived quantity cannot exist without a fundamental quantity. Derived quantities cannot exist without a what? Fundamental quantity. So for speed, we have distance over time. There is a fundamental quantity here, time. There is also another fundamental quantity, distance. This is also another fundamental quantity, distance, which is measured in what? Meters. And this is measured in what? Seconds. Take notes. Similarly, this is measured in what? Seconds, and this is measured in what? This in meters. So this is displacement over time for speed, and this distance over time for speed, and displacement over time for what? Velocity. Beautiful. So who can tell me which car this is? Is this a Benz, a Lexus, a Volvo? Let me know in the comment section your favorite car. Please let me know in the comment section. Let me know your favorite car. Is this a Benz, BMW, Lexus? Let's know. Then, if you are done writing, let's proceed. If you are done writing, let me know so we can proceed. If you are done writing, let me know so we can proceed. Then type your favorite car. Let's know what's your favorite car. Benz. Oh, someone said Benz. Okay, beautiful. What's your favorite car? Let me know. If you're done writing, okay. Christian is done writing. Benz. All right. Is this a Benz? Is this Lexus? Is this Toyota? Is this Ford? Which one? Which one? Which one? Which one? Is it Tesla? Is it a Volvo? So let me know your favorite car. Then right there. Oh, Supra MK4. Beautiful. We have some hot cars section. Beautiful. Wow, 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 wow. Okay. You can screenshot it or you write it down so we can proceed. Let's go, let's go, let's go. So moving on, I'll give you some examples of fundamental quantities. Examples. So we have the quantity, we have the word formula, and we have the word units. So we have quantity, we have formula, and we have units. So an example of a derived quantity. Oh, Lamborghini. Who said Lamborghini? Oh, Peter Amadi Lamborghini. Confidence, BMW. That's your favorite car. Beautiful. Yes, yes. You can get any car you want. Yes, you just have to make sure you first of all finish the important things in your life. Then that will give you energy to make more money to get whatever car you want, whatever dream car you want. That's why this year you must get your dream school and your dream course, so that from there you can start building on that. Then you get your dream car too, your dream school, you get your dream school, you get your dream course, and you also get your dream car. If it's BMW, Lamborghini, Benz, Tesla, anyone, Volvo, you get everything. So stay with me. So who can let me know one derived quantity? One derived quantity. I've mentioned two already before, so you can still repeat it in case you cannot remember any other one. Let me know one derived quantity. Example, drop it in the comment section. Drop it in the comment section. Drop it in the comment section. Let's know one derived quantity. One derived quantity. Let's know. Let's know. All right. All right. Let me see what you have there. One derived quantity. Drop it in the comment section. Drop it in the comment section. Okay. We have velocity. And the formula for velocity is what? Meters over what? Seconds. And the unit, you can write it like this, meter per second. Now note, meters over second. Let me write it in a way that you will not get confused. Let me write it this way. Meters over seconds. And why this is -1 is that this now, from our laws of indices, if we want to convert this, you have to 1 power -1. So this is the same thing as m over 1 times 1 over s, which is the same thing as m times s raised to the power -1. Right? So 1 over s is the same thing as s raised to the power -1. So that's how we got this ms raised to the power what? -1. So you will not be confused. So this is the formula for velocity. Meters over seconds. Remember, this is what? Distance over time, right? Distance over what time? Distance over time. And in distance is measured in what? Meters. Is the length of something from one point to the other, and time is measured in seconds. So the formula will give us meters over seconds, and if we convert it, we'll have a unit ms raised to the power -1. Alright, someone says speed. Speed is also similar. You also get the same unit for speed. For distance, you get the same unit. For speed, you get the same unit. So let's go. Force. For force, we have mass times acceleration. Which is equal to what? MA. Mass acceleration for force. Mass times acceleration. And the unit for force is what? Newton. The third one is what? Density. Which is what? Mass over volume. And remember, beautiful acceleration, beautiful area, force, beautiful density, beautiful speed. That is beautiful. For density, we have mass over volume. Mass, remember, we measure mass in what? Kilogram. We measured mass in what? Kilogram. And for volume, we have what? Length times height, right? And for length is also measured in what? Meters. Breadth is also measured in what? Meters. And height is also measured in what? Meters. Right? So we will have over meters times what? Meters. I see it. So meter times meter will give us meter what? Kilogram per what? Meter cube. Right? And remember, see the way we did this one, we'll now do the same thing for this. So we can write density to what? Kilogram raised to the power -3. Minus what? 3. That's it. Then let's look at pressure. Pressure. For pressure, force, work times distance. Beautiful. Work times, wait, did you say work times force? Okay, work equals to force times distance. Sorry. Work equals to force times distance. Okay. We'll write number 5, work. Okay, there's no space, but let's just read it out for those that are there. Force equals to work equals to force times distance. That's what confidence said. Beautiful. While confidence also said that acceleration is equals to velocity over time. Beautiful. Mandy Peter said force is a fundamental, is a derived quantity, area is a derived quantity. Okay, let's look at this. Christian Gloria says velocity. All right. So pressure. For pressure, we know that pressure is equal to what? Force over area. Over area. And we know that force is mass times acceleration, right? Then area is what? Length times breadth. And for length is also measured in what? Meters. And breadth is also measured in meters. So length is measured in meters, breadth is measured in meters. So we have what? Force, that is mass over acceleration times m times m, which will give us what? For force, we have Newton over what? Meter what? Square. So we'll write it here, Newton meter what? Square. So this is for pressure. We know that mass times acceleration is what? Newton. Look at it here. I know that meter times meter will give us meter square, because area is length times breadth. Length is measured in meter, breadth is measured in meter. So when we combine the both of them, and from our both of this, we can write it as what? Newton meter, Newton per meter square. Alright, if you're done writing, let me know. If you're done writing, let me know. So we can solve one example. If you're done writing, let me know so we can solve one example. If you're done writing, please let me know so we can proceed. Are you done writing? Let me know. Right, I'm done writing. Alright. Christian's faith glorious is done. Let's go. If you're done writing, let me know so we can proceed. Done. Beautiful. Let's go. That's beautiful. Done. Toxic is done. Who else is done? Let's know so we can proceed. Alright, let's go. So let's solve one example, very simple example, so we can move fast to prefixes. Proceed. So this example will be very simple. Example, let's convert let's convert 5 cm towards meters. But before we do this example, I'm supposed to show you prefixes. Yes, I'm supposed to tell you about prefixes so you will not be lost. So let's go to prefixes first before we show our example. Good. Let's go to prefixes. So prefixes. Let's go prefix. All right. So I'll give you some examples of prefix that you should know. Very important. So prefix, symbol, you should know this, very important, and value. So for this, you should know this. Kilo, you should know kilo is K, the symbol for kilo is K, and is what? 10 raised to power 3. You should also know centi. Remember centi is C, and is what? 10 raised to power minus 2. You should know milli. These are common prefixes that you see. Milli is small m, centi is small m, and is 10 raised to power minus 3. You should know micro. These are common examples you see in your JAMB, which is 10 raised to power what? Minus 6. Very important. You should know nano, which is small n, which is 10 raised to power what? Minus 9. And you should know mega, which is capital M, which is 10 raised to power plus 9. So these are prefixes that you should know at the back of your hand. So I'll advise you to memorize them. So this will be another of our memory verse. After we finish reciting our fundamental quantities, we will recite the prefixes every day so we can be familiar with them. So kilo, 10 raised to power 3. Now, let me do something for you. This is the same thing as what? 10 times 10 times 10, which is equal to 1000, right? This is equal to 10 times 10 times 10, which is 1000, right? Why this is same thing as what? 1 over 10 times 10, right? Which is equal to what? 1 over what? 100. And for 1 over 100, let me bring it here. 1 over 100. If you cancel this 0, you move here. You cancel this 0, you move here. The decimal point will now be here, right? So you will be having what? Centi as 0.01. 0.01 in what? That's if you are putting it in the fundamental quantities. This will be in what? Meters. This will be in what? Meters. So this is simply converting it to what? Meters. Kilo is 10 times 10 times 10, that's 1000 meters. 1 kilometer will give you what? 1000 meters, sorry. Why? 1 centimeter will give you 0.01 meter. This is how we got it. 10 raised to power minus 2, same thing as 1 over 10 times 10. You get? Because of, remember, we did something like this. 10 raised to power minus 2 is same thing as 1 over 10 raised to power 2. So from this 1 raised to power 1 over 10 raised to power 2, we now did 1 over 10 times 10. 10 raised to power 2 is what? 10 times 10. We now go to 1 over 100. And from our division, when you cancel out 1 0, you move towards the left. You cancel again, you move towards the left. So see where our decimal point should be. It's now be 0.01. Similarly, for milli, which is 10 raised to power minus 3, will be what? 1 over what? 10 raised to power 3. And it's 1 over 10 raised to power 3. It's still the same thing as what? 1 over 10 times 10 times 10, which is what? 1 over what? 1000. And if you divide it, 1 over 1000, if you cancel that 1 0, you carry it here. Cancel that second one, you carry it here. And you cancel out the third one, you carry it here. You put your 0, you put your 0. So this is where your decimal point will be. So it's now be what? 0.001. 001 in meters. So we are converting all of them to what? Meters. That's the same way you do for all of them. So if you understand this explanation, please write in the comment section, I understand. Please write in the comment section, I understand, so we can proceed. And if you've written down everything, Also write I'm done writing so we can proceed. Let's go, let's go. If you're done writing, please let me know so we can proceed. If you're done writing, let me know so we can proceed. And if you understood this explanation, please write I understand. Let me know so we can proceed. Very important. Are you done writing? Are you done writing? Let's know so we can proceed. All right, I understand. Proceed. Beautiful, 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 beautiful. Toxic has said it. He has understood it, so we can proceed. All right, so let's move on to the next thing we have. Please make sure you memorize this. Please make sure you memorize this. All right. So let's take the example back now. Example. So in our example, we have to convert what? 5 cm to what? Meters. And we have to also convert 3 minutes to what? Seconds. So solution. 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 So now, are you here with me? I'm about to solve this example. So you can solve it and drop the answer in the comment section. Convert 5 centimeters to meters and convert 3 minutes to seconds. Let me see your answer before I continue. Let me see your answer. Please let me see your answers before I continue. Drop it in the comment section. You have 1 minute to do that. Please, let's go. 1 minute to solve it. Please convert 5 cm to meters and 3 minutes to what? Seconds. Let me know. 3 minutes equals to 180 seconds. Beautiful, beautiful. So someone says 3 minutes is equals to 180 seconds. We'll confirm that very soon. So what about the 5 cm? 5 cm. 5 cm is equals to 0.05 meters. Someone else said, okay. All right, 0.05 meters. All right, is that all? So let's solve it together. So for the first one, 5 cm to meters, we know that 1 cm is equals to what? 10 times 10 raised to the power minus 2. We know that cm is what? 10 times what? We know that cm is what? Let me write it like this. 5 times, okay, 6 same thing. 10 raised to the power what? Minus 2. I'm going to write it like this. Cm equals to 10 raised to the power what? Minus 2. So if we do this, it's the same thing as what? 5 times what? 1 over 10 raised to the power 2. And we will now have that what? 5 times 1 over what? 10 times 10, which is equal to 5 times 1 over 100, which will now give us what? 5 over what? 100. And 5 over 100 is simply what? You cancel here, you carry here, you cancel here, you carry here. See where our decimal points will be. So we'll have what? 0.05 what? Meters. So the person that got this answer is what? Correct. Toxic. You're correct, you're correct, you're correct, you're correct. So this is how you solve it. 5 cm, when we know that 1 cm is equal to 10 raised to the power minus 2. So 5 cm will be 5 times 1 cm, that's 5 times cm. Then you break it down like this: 5 times 1 over 10 raised to the power 2, 10 times 10, 5 times 1 over 100. You divide and you get your answer. Very simple. Hope you understand this. If you understand, write "I understand" in the comment section. So this is number 1. Number 2, we'll convert 3 minutes to seconds. We know that 1 minute equals to what? 60 seconds. So 3 minutes will be 3 times what? 60, which will give us what? 180 what? Seconds. So the person that gave us 180 seconds is what? Correct. So you all are understanding what we are doing. All right, beautiful, beautiful. So we can proceed, right? If you've written this down, let's know so we can proceed. If you have taken this example down, please let me know so we can proceed to measuring instruments. So we can proceed to measuring instruments. Write done. If you are done writing, write done so I can clean and we can proceed to what? Measuring units. Measuring instruments. If you're done writing, let me know. Write it done in the comment section so we can proceed. Let's know if you're done writing. Write "I'm done writing" so we can proceed. Write "I'm done writing." Write "I'm done writing." I'm done writing. Write in the comment section. Done. Okay, let's go. Beautiful, they are done. So now we'll go to measuring instruments. Measuring instruments. So who can tell us some measuring instruments we have? Measuring instruments. Measuring instruments. So measuring instruments we know. Please let us know quantity. And instrument. So let me know the quantity and the instrument. Let me know in the comment section the quantity and the instrument. Let me know the quantity and the instrument. Meter rule, beautiful. That is for length. Meter rule. You use meter rule to measure length. Alright, toxic. Toxic says we use meter rule to measure length. Beautiful. So let's see if we can draw a simple meter rule here. So this is 1, 2, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2. So this is our meter rule. Now 5, 10, 15, 20. So this is our meter meter rule. So this is our meter. Another, all right, confidence set understood, beautiful. So another measuring instrument we have for very small lengths, for very small lengths, very small lengths. Who can tell us very small lengths? We will use vernier caliper. For very small lengths, use what? Vernier caliper. Vernier caliper. Then for extremely small length, that's very, very small length. Very, very small lengths. For very, very small lengths, we'll use what? Micro screw gauge. Micrometer what? Screw gauge. Screw what? Gauge. So I'll be showing you what a vernier caliper looks like. I'll also be showing you what a micrometer screw gauge looks like. So stay with me. I'll show you what the vernier looks like and the micrometer screw gauge, what it looks like. Okay, let's look at vernier caliper. So this is our vernier caliper. Let me show you what the vernier caliper looks like. Please stay with me. I'm coming. I'll show you what the vernier caliper looks like. I'll show you what the vernier caliper looks like. So look at what a vernier caliper looks like. This is what the vernier caliper looks like. Can you see it? If you can see the vernier caliper, let me know. This is what the vernier caliper looks like. This is it over here, the vernier caliper. This is the vernier caliper. So now let's also look at the micrometer screw gauge. Let me show you what the micrometer screw gauge looks like. Micrometer or screw gauge. For the micrometer screw gauge, this is what it looks like. This is the micrometer screw gauge. So in case you've not seen it before, this is how the micrometer screw gauge looks like. Please take note of this. Or should I draw it on the board? Should I draw it? You can take a snapshot on it. This is what the micrometer screw gauge looks like. And the vernier caliper. Let me draw it. Let me just draw a bit of it. Okay. Or just take a snapshot. Let's not draw it so we'll not waste so much time. Alright, beautiful, beautiful. If you're there with me, let me know. If you're here with me, let me know. The vernier caliper, the micrometer screw gauge. So let's go, let's go. Can you hear me? Have you seen it? Yes, you've seen it. Doxy said he has seen it. So let's proceed, let's proceed. Let us proceed. Beautiful, beautiful. If you have seen it, we can proceed now. Can you see the board? Can you see the board? Can you see the board? Let me know if you can see the board. Let me know if you can see the board. Oh no, the board is not showing. Let me know if you can see the board. Let me know if you can see the board. Let me check. Oh shit, I was not charging my phone. Alright, I think we'll continue with the electronic board. My camera just went off. So we'll continue with the electronic board. We'll continue with the electronic board. Let me power my phone. I'm coming. I'm coming. I can't. I know you cannot see the board. I know you can't see it. I'm coming. Let me power my phone. Let me plug my phone. My camera just went off. Let me plug it so that we can continue with the whiteboard. Let me plug it so we can continue with the whiteboard. I did not check my battery percent. All right, all right. I'll plug this in. All right, can you hear me? If you can hear me, you can see me, let me know. Okay, while my phone is charging, let's have a little bit of conversation. Let's chat a bit. All right, can you hear me? Can you see me? If you can see me, you can hear me. Let's know. You can see me, you can hear me. My phone is charging, so it will be coming on very soon. So we'll continue our class. So while it's charging, let's talk for a while. Let's communicate. Let us communicate. While you can hear me, you continue with the electronic board, or we should wait, let the phone charge small. The phone will charge for like 3 minutes or 5 minutes, then we'll continue. Okay, you can see me. Yes, you can see me. Toxic says yes, he can see me. So let's know if you can see me. The phone is charging. It's charging, so we can continue our class. We can continue our class. Sorry for the break in transmission. So we can continue our class. I'm coming. Let me check this thing. I'll be right back. I'm coming. Let me check the. You can see me, right? Okay, we can proceed. Let me check if the phone has finished charging. So I can turn it on and the camera can start kicking off. All right, just give me a second. Give me a second. Give me a second. Thank you very much. We would wait. Beautiful. I love that energy. That's the energy I love. We would wait. Okay, it's loading. I'm coming. Phone is coming on. It's coming on. Just give me like 3 minutes for it to boot, for it to load. It's loading. So you can tell me, what have you learned so far in the comment section? What have you learned so far? Tomorrow we'll be touching maths. Today is physics, measurement and units. Tomorrow is maths. I'll drop the timetable on the WhatsApp group. Yes, I'll drop it on the WhatsApp platform. So tomorrow is maths. The next one will be chemistry before biology. We'll be moving sequentially. Stay with me. We'll be done in a very short moment. All right, let's go. Let me check if my phone is on. Okay. me, you can see me, then we can proceed. Beautiful. Okay, let's proceed. Let's proceed. Okay, my camera should be ready by now. Let me check it out so we can continue from where we stopped. Ready by now. It should be ready. It should be ready. The camera should be ready. I can see you. Beautiful. So let me check the camera so we can continue. Okay, it's still booting. It's still booting. It's loading. Still booting. All right. So let's just give the phone 3 minutes or 5 minutes before we proceed. Yes. I don't want to continue the electronic board because of the bit. The electronic board, maybe I'll use that one to make a pre-recorded class for the electronic board own because of the paste. If we use this one, we will not be that fast, but the whiteboard is better. If not, I'll have said let's continue here. You get? So we will continue with the whiteboard. So we'll continue with the whiteboard. Okay. All right, all right, all right. Hope you're enjoying today's class. Yes, we'll be having the class by 7 p.m. as discussed. Beautiful. Yes, yes, yes. We'll be having the class earlier. Today, I had to set up one or two stuff so that everything will flow naturally. Sorry for the 2 hours delay. Yes, we're supposed to start this class by 7 p.m. We're supposed to kick off by 7 p.m., but we had to push it to 9. So I'm sorry for that. I'm very sorry for that. Tomorrow we'll start earlier. We'll start by 7 o'clock and we'll finish by 9 o'clock. So both our WhatsApp section and the YouTube section, 2 hours should be okay to cover up everything we need. So I've stretched you. This is part of the sacrifice we talk about. Sacrifice your time, your energy, and your resource so that you are sure of entering into your dream school and your dream university. Sorry about today. Yes, I mentioned that derived quantities won't exist without fundamental quantities. You're very right about that. Yes, yes. Without fundamental quantities, then there cannot be any derived. Without fundamental quantities, there cannot be any derived quantities. All right, confident. Following up the class, that's beautiful. What else? What else have you learned today? Let me know. Let me know. Toxic, can you hear me? Okay, thanks. You're welcome. You're welcome. Much love. So please make sure you share this link to your friends, your classmates in secondary school. If you just finished secondary school, but if you've left school for a long time, no problem. Please share to your friends, share it to everybody that you know that is going to take this 2026 JAM. So we can also carry them along now that we are starting. So they will not be confused when they join us in between. This is the best time. Okay. Confidence pressure said. I also said that fundamental quantities are base quantities. Beautiful, beautiful. Yes, yes, yes. That's good. That means you're taking note down. That's good. That's good. Beautiful. Let's go. Let's go. Peter Amadi, Chris, Faith Glorious, Faith Glorious. Okay. Peter Amadi. Okay. Where are they? Toxic. Okay. Let's go. Let's go. Check if the camera is on so we can continue. Okay. Let me check. Let me check. Okay, the phone is on finally, so we can continue. We can continue. We can continue. Beautiful. All right, that means we can continue from where we stopped. Yes, we can continue from where we stopped. We can continue from where we stopped. I'm loading the camera so we can continue from where we stopped. All right, we are back. We are back. We are back. We are back. Beautiful, beautiful, beautiful. We are back. The camera is rolling. We are back. We are back. We are back. Yes, that is beautiful. So let me set it up. We are back. We are back. Everything is set now. So we can from where we stopped and continue from where we stopped. Yes. We can continue from where we stopped. Beautiful. We can continue from where we stopped. Yes, 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 yes. We are back. Let's go. And continue from where we stopped. All right, all right. Let's continue from where we stopped. Continue from where we stopped. Thank you for staying with me. Thank you so much for staying with me. Thank you so much for staying with me. We are back live. Let's go. All right. So we are back. It's loading. Okay. Toxic said he had a question. Okay. Let me know. Tell me your question. Tell me your question. Let me know your question. Can you see the board now? Let me know your question. Toxic. Okay, it was mentioned that derived quantities are gotten from two or more fundamental quantities. That's beautiful. Confidence. That's beautiful. All right, so let me know. Let me know. Let me know. What is your question? What is your question? Let me know your question. Let me know your question. Let me know your question. So let's continue from where we stopped. Toxic, you can let me know your question. Tell me your question. What is your question? You say you have a question. All right, so for quantities, we have time. We have time. Can you see the board? Is it showing? Is it clear? We have time and we use stopwatch towards major time. The fifth one, we have mass and we use the balance to measure it. So these are some quantities and the instruments we use to measure it. So I'll be showing you stopwatch and I'll also be showing you the balance. I'll show you a stopwatch and I'll also be showing you a balance. Yes, a stopwatch and a balance. I'll be showing you a stopwatch and I'll be showing you a balance. So, so this is our stopwatch and this is our balance. If you can see our stopwatch, you can also see our balance. Let me know in the comment section. So this is the stopwatch. This is the stopwatch. This is the stopwatch. Yes, this is stopwatch. These are different types of stopwatch used to measure time in seconds. And this is our spring balance used to measure mass. So this is what a spring balance looks like. We also have different type of balance that you can use to measure mass. So this is where you see where they are loading it with different masses. So we have our spring balance and we have our what? Stopwatch. So let's continue. Let's continue to what we have today. Okay, Toxic is asking, he said, since acceleration is so fundamental in motion, why isn't it considered as base quantity instead of being derived from length and time? Beautiful. That's a very important question. So for acceleration, Toxic is asking us, why is it that acceleration is not a fundamental quantity, is a base quantity, is a derived quantity? Acceleration now, let's answer Toxic. Acceleration is nothing from what? Change in velocity over time, right? So if we draw our velocity time graph, we will know that, or let me not take you too far, let me just answer the question direct. Acceleration is very important, but it cannot be a fundamental quantity because there is velocity inside, and velocity on its own, velocity is equal to what? Distance over time. So even velocity itself is not a fundamental quantity, it's a derived quantity that is derived from distance over time. And velocity is also very important in motion. And now from this velocity now, the change in velocity over time will give you acceleration. So acceleration is, before you get to acceleration, there are so many processes that are going on in motion. So that's why acceleration cannot be a fundamental quantity, but it has to be a what? Derived quantity. Toxic, do you understand the explanation? Please, if you understood the explanation, let me know so we can proceed. And if you've taken this down, if you've written everything here, please let me know so we can proceed to the next thing we have, which is error in measurements. Error in measurements. Error in measurements. After we finish error in measurements, we'll check out significant figures and standard form. Then we'll be done for tonight. Errors in measurements. Yes, I do. Thank you. All right. Toxi said yes, he do. He understands it. Thank you very much. So you can proceed. Have you written this down so I can clean it? If you're done writing, say I'm done writing in the comment section so I can know, so I can clean it up. If you're done writing, let me know. Say I'm done writing. You're done writing. Can I clean? You can take a snapshot or a screenshot. You're done writing? All right. Let's proceed. All right. So we'll look at what? Error in measurement. Don't proceed. Beautiful. Don't proceed. Alright, so we have errors in measurement. We have different types of measurements, different types of errors. Errors in measurements. This is very important, especially in your laboratory work and experiments. You need to be careful so you do not experience these errors. We have different types of errors in measurements, different types. We need to be careful. So the first type of error we have is what? Systematic error. And this is as a result of what? Faulty instruments. Faulty instruments. Please take this down, write this down. Systematic error as a result of faulty instrument. Example, the zero error. The zero error. Now let's say imagine now you're using a ruler that has broken. Now the ruler, because of the ruler has broken, you cannot measure from the beginning. So you will not get the exact point or zero. You will now push it forward because you are using a broken ruler. That can cause systematic error due to what? Faulty what? Instruments. You get? So another example of error we have is what? Random error. Random what? Error. This error is as a result of human mistakes. Human mistakes. So imagine you are tired and you're doing a practical. If you're tired and you're doing a practical, you are prone to making mistakes. So we have the random error, which is as a result of human mistake, fatigue, tiredness. Maybe the person is having poor eyesight and the person is supposed to look at a reading. Because of the person's eye is not good, the person is looking at it and is not seeing it well. That's another error they call error due to parallax. You are not seeing properly, you are not looking at the instrument properly. So these are types of errors that we encounter. So let's move on to what? Accuracy versus precision. Accuracy versus precision. Let's go. Accuracy versus precision. What does it mean to be accurate? Who knows? You can let me know in the comment section what it means to be accurate versus what it means to be precise. Does anybody know what it means to be accurate versus what it means to be precise? Okay, Christian says he's done writing. Beautiful. What is accuracy and what is precision? Let me write it down. Accuracy is simply close to the real value. Now, when you're taking measurements during practicals, you don't just take one measurement, you take multiple measurements so you can take the average of that measurement. For instance, now we have like 10 runners doing a race and you want to check their average speed. When you take all the speed, you will not take the average of it. But while recording, if let's say the average speed of my alarm is coming, let me put my phone on do not disturb. It's on do not disturb. My alarm, sorry, my alarm was disturbing. So let me continue. For instance, accuracy, if you're taking measurement of, let's say, different runners, let's say 9.81, 9.88, 9.89, 9. Are you seeing? But the original value now is what? Let's say 9.85. That's the average speed of an Olympic runner. Let's just assume that's the average speed of an Olympic runner. And now, accuracy now. This is the real value, right? And you're getting 1, 2, 3. They're all close to this value. So your results can be classified as what? Accurate. Because it's close to the real value. While precision is close to each other. This is for accuracy. For precision, now still this 9.85 as the average speed. But now during your measurements, you start getting values like 7.01, 7.03, 7.05. This result you're getting now is precise because they are close to each other, but it's not accurate. But why this one is close to 9.85, this result 9.81, 9.88, 9.9, they are all close to 9.85. So you can say this is accurate, close to the real value. Why this is precise but it's not accurate? They are similar, 7.01, 7.03, 7.05, but they are not what? Accurate. So that is the difference between accuracy and precision in what? Measurement. So these are still under errors in measurement. You need to take note of this. Systematic error due to faulty instrument. So if you are done writing, let me know so I can clean the board. If you are done writing, write it in the comment section. Done writing so I can clean and proceed. Let me know so I can proceed. If you're done writing, please let me know so I can proceed. Are you done writing? Let me know. If you're done writing or you can take a screenshot, let me know so I can proceed. So moving on, we have significant figures. These significant figures, it can be very tricky sometimes, so please pay attention. Pay attention to these significant figures. I'm cleaning the board. I believe everybody. Okay, so precision is how consistent you get a value. Yes, yes. Precision is how consistent you get a value. Correct. Toxic is correct. Precision is how consistent you get a value. That is very correct. That's what toxic say. All right. Beautiful, beautiful, beautiful. That is beautiful. Yes, beautiful. So if you're done writing, let me know so I can proceed. You can also take a screenshot of what is on the board. So can I clean? Can I clean? Moving on, let's go. I believe you should be done writing by now. Are you done writing? Are you done writing? Should I wait? All right, let's go, let's go, let's go. Okay. So we are moving on to what? Significant figures. Significant figures. So significant figures. Please, this topic, significant figures, very important. Why I say very important, can be very tricky sometimes. So we can say significant figures. Take note, please take note. These are figures that carry meaning. or accuracy. These are figures that carry what? Meaning or accuracy. It carries what? This thing or accuracy. Alright. These are meaning or accuracy. Significant figures helps us to know how accurate it is. Now let's say we divide a number and we are getting, let's say, 3.5934287 and so on. So we're not gonna write this thing now as our final answer because it's too long. And if we just take 3, let's say this is a very big measurement. Let's say this measurement is in kilometers. And we take just 3. Let me say we measure the length of the road. Or let's say we measure the length of the road and we say the distance of the road is just 3 kilometers. Why is supposed to be 3.5 kilometers? We are actually wrong because this other part of the road, how are we going to design it if we don't know the exact number? These significant figures shows accuracy and it's very important, especially when you are dealing with large numbers. You can ignore it if this was to be in millimeters. That is very small. You will know it's negligible, it's very small. But since it's in kilometers or meters or any big unit, you have to take note of it. Because if you put this 3.5, let's say 3 now, you took only 3 minus 3.593, so now equals to 0.593, right? This 0.593 is still in kilometers, sure you know. And if you convert this 0.593 to meters, it will be times what? 1000, which will give us 593 what? Meters. Imagine how big this value is and you ignored it. Imagine how big this value is now. Let's say this remaining part is now 593 what? Kilometers, 593 meters. Imagine how big it is. And because of you are writing now, you just calculated and your value gave me 3.593428, and you just decided on your own that you should ignore these other values after the decimal and write only 3 meters. No, it's not correct. So you have to put your answer in at least 2 significant figures or 3 significant figures so that this remaining value now will also be put into consideration. You get? Because it's also a very big value, it's a tangible value. So that's what significant figures help us to do. It helps us to show accuracy. So we'll not just be throwing away values, we'll round them off to at least 2-3 significant figures. The more the significant figure, the more the accuracy. Take note. The more the significant figure, the greater the accuracy. The more this alarm, the more the significant figure, the greater the what? The more the significant figure, the greater the what? Accuracy. So the more the significant figure, the greater the what? Accuracy. Please take note. If you're done writing, let me know so I can clean the board. Let me know so I can clean the board. This 3 kilometers is also what? 3,000 meters. So you can write meters or 3 kilometers, which will give us a total sum of what? 3,593 what? Meters. That you add these two to get the total length of the road. So please let me know if you're done writing so we can proceed. Are you done writing significant figures? Write done writing significant figures so we can proceed. Let me know. Let me know if you're done writing the significant figures so we can proceed. If you're done writing, please let me know so we can proceed. If you're done writing the significant figures, please let me know in the comment section, done writing significant figures so I can proceed. You can also take a screenshot so I can proceed. All right. Toxic said done writing, so we can clean. So let's solve some examples of significant figures. So let's take some examples and things you need to know about the significant figures. So I'll be giving you some rules that you need to know. Rule number one for significant figures. All take note, please. Rule number one, all non-zero numbers count. Rule number one, all non-zero numbers count. All non-zero numbers count. For instance, we have 223, we have 567, and we have 8942. So if we ask how many significant figures are these, this is 1, 2, so this will be 2 significant what? Figure. 2 significant figure. Why this should be what? 3 significant what? Figure. And this should be 1, 2, 3, 4. 4 significant what? Figures. That's rule number one. All non-zero numbers what? Count. So let's go to rule number two. Rule number two. Rule number two. Rule number two. Zeros between numbers count. Zeros between numbers count. For example, zeros between numbers count. 1, 0, 0, 2. For example, 3.05. We have 4007. So this is rule number two, which says all zeros between numbers count. All zeros between numbers count. So this will be what? 4 significant figures. 1, 2, 3, 4. So it will be 4 significant figures. This should be 1, 2, 3. All zeros in between the numbers. This zero is in between 3 and 5, so it counts. So this should be 3 significant figures. And this should be 4. 1, 2, 3, 4. 4 significant figures. So if you understood this explanation, please let me know. Please let me know. Do you understand this first rule and second rule? So we can proceed to the next rule. Please let me know in the comment section if you understood the first rule and second rule so we can proceed. Let me know what let me know if you can understand, if you understood the first rule and second rule. Write I understand, proceed. If you understood the first rule and second rule, let me know so we can proceed. Please, 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 let's go. Let's go, let's go, let's go. All right, yes, well understood. Proceed. Okay, let's proceed to the next rule, which is rule 3. So for the next one, the third rule, rule number 3. Rule number 3 says, take note please, leading zeros don't count. Zeros before first numbers are useless. Zeros before first numbers are useless. Leading zeros do not what? Count. Leading zeros do not count. Therefore, zeros before first numbers are useless. Therefore, what? Zero before first numbers are what? Useless. For example, let's have 0.0025. Another example, let's say 0.00061. Then let's say the final example, 0.04. This should be okay. So now, he said leading zeros. So these zeros are leading. These are, if you're counting from left to right, right? If you're counting from left to right. You're counting from left to right. So all these zeros are the ones leading. They don't matter. They are useless. Leading zeros do not matter. Zeros before the first number. This is the first number. This is the second number. They don't matter. So this will be what? 1, 2. Useless. Important. So it will be what? 2 significant what? Figures. And this also 1, 2, 3, 4. They are leading zeros, so they will be ignored. This will be ignored. This will be ignored. So we left with 61, which was 2 significant figures. And this final one, this will be ignored. This will be ignored. So this is the first number. So we'll call it what? 1 significant what? Figure. So this is for the rule 3. Leading zeros do not count. Zeros before first numbers are what? Useless. Please write this down. Very important, because if you're using them after you have done your measurements, you need to leave your answers in the correct significant figures. So we'll take rule number 4 and rule number 5. If you've written it down, let me know so I can clean and we can proceed. Or you can take a screenshot so we can proceed. Rule number 4 and rule number 5. Let's go. Rule number 4 and rule number 5. Let's go. Are you done writing? Alright, if you're done writing, we can proceed. So rule number, okay, understood. Faith Gloria said understood, beautiful. Faith Gloria said understood. Pressure said proceed, fully understood, beautiful. So let's go to rule number 4. Rule number 4. Rule number 4. Rule number 4. Ending zeros after decimal count. Ending zeros after decimals count. Ending zeros after what? Decimal count. What? Count. Ending zeros after decimal what? Count. For example, 2.50, another one. For example, 2.50, another example, 6.000, and the final example, 3.40. So we need to know that any zero after decimal point count. So this is our decimal point, this is our decimal point, this is our decimal point. So ending zero, these are the zeros ending it. Look at them. You know, we are counting, we are checking our significant figures. We are always going from left to right. From left to right, right? So this is the starting and this is the ending. So ending zeros count. So this will be what? This is what? 3 significant figures. 1, 2, 3. This zero count just at the ending, after the zero, after the decimal point, so it will count. These other zeros, the 3 of them will count because they're after the decimal point, they're ending zeros. So this will be what? 4 significant figures. And this 1, 2, 3. This zero will count because at the ending and it's after the decimal point. So this will be what? 3 what? Significant what? Figures. Please take note, please take note of this. Take note of this. We are moving from left to right. Take note of this. These zeros count. So we'll move to the final rule. That is rule number 5. We'll move to rule number 5. Then we'll solve some examples. Then we'll talk about standard form and call it a day. So let's proceed. If you've taken this down, let me know. Don't write in. Okay, don't write in. So you can also take a screenshot. Let's go. Rule number 5. Let's go. Rule number 5. Let's go. Rule number 5. Rule number 5. Rule number 5. For rule number 5 says whole numbers, take notes. Whole numbers with zeros are tricky. Whole numbers with zeros are tricky. I'll show you why. Whole numbers with zero are what? Tricky. Whole numbers with zero are tricky. Here is why. For example of a whole number with zero. Let's take an example. Example. Let's say 200. Example 2. We don't know whether it's 1 significant figure. We don't know whether it's 2 significant figure. We don't know whether it's 3 significant figure. We don't know which one. We need to use standard form. We don't know. if it's what one significant figure, two significant figure, or three. So since we don't know whether it's one significant figure, two significant figure, or three significant figure, we need to use what we call standard form. So we use standard form. Standard word form. So if we write this in standard form, we can bring out three different types of standard form. If we write this in standard form, we can write this same 200 in three different ways. And you will see that we'll still arrive at the same thing. But it's what? Two significant figures. We can write it as 2 times 10 raised to the power 2. That is 1. We can also write it as what? 2.0 times 10 raised to the power 2. That is another one. We can also write it as 2.00 times 10 raised to the power 2. So if you look at this, 2 times 10 raised to the power 2 will still give us 200. 2.0 times 10 raised to the power 2 will give us 200. And 2.00 times 10 raised to the power 2 will also give us 200. And from our first law, we say that whole numbers, all non-zero numbers count. And this is a non-zero number. So if it counts, that means this should be in what? One significant word figure. And from our fourth law, we say that zeros after the decimal or ending zeros count. Zeros after the decimal count or ending zeros count. Remember from our fourth law, they said ending zeros after the decimal count. So if we count this one to be 1, 2. So this will be what? 2 significant figure. And this will be 1, 2, 3. This will be what? 3 significant figure. So you see why we say whole numbers with zeros are tricky. This is the reason why we say whole numbers with zeros are tricky. Because we cannot tell if it's 1 significant figure, 2 significant figure, or 3 significant figure. So we have to convert it to standard form. And depending on the way you convert it to your own standard form, that's depending on the significant figure you will get. So this is what significant figures look like and what standard form looks like. So I'll give you some examples that you just convert and let me know in the comment section. We are done for today. I'll give you some examples. You let me know. Then on our platform, our WhatsApp community, that's our WhatsApp group, I'll drop some practice questions that you do and submit before our next class. So let's just solve some examples and we'll call it a day. So if you're done writing this, please let me know. If you're done writing this, let me know so we can solve an example and call it a day. If you're done writing, write proceed to examples on the comment section. Write proceed to examples in the chat box. Write proceed to examples. If you're done writing, please write proceed to examples. Please write proceed to examples. If you're done writing, please write proceed to examples. If you're done writing, please write proceed to examples so we can continue. We are done. We are almost done for today. But we're done in the next 5 minutes. We are out of here. In the next 5 minutes, we'll be done. Proceed to examples. Beautiful. Talks is proceed to examples. Beautiful. So we can clean. Beautiful, beautiful. So let's solve some examples. So the first example will be what? Example Write what 0.00450 in what significant uh, write 0.00450 in what significant figures. And example two, this is example one, this is example one, example two, round 3.786 to three significant figures. So these are examples. So solve this and drop it in the comment section, then we'll call it a day. Please solve this and drop it in the comment section and we'll call it a day. Please write this and drop it in the comment section. Or should I give one more example? Okay, let's give one more example, number 3. Let's say write 4500 in standard form. So solve this, drop it in the comment section, and we are done for today. Thank you for staying to the end of the class. Write this, drop it in the comment section, and we are done for today. So I'll give you 2 minutes to solve this example on significant figures. Please solve these examples for significant figures. So in case you're just coming now, just do a recap of everything we've learned today, or I'll drop it in the comment section. Please solve this example 1, 2, 3. Drop it in the comment section and we'll call it a day. So, all right, this significant figure, beautiful, 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 beautiful. Beautiful. So I will be dropping the group link. I will be dropping the group link in the description. So I'll be dropping the group link. I'll be dropping the group link. Your answer was correct. You rejected the message. Why? Write it in the comment section. Let us know. Let us know. Please let us know in the comment section. All right. Let me solve this with you. Let's solve this together. Let's solve this together. Then we'll call it a day. Let's solve this together. Then we'll call it a day. All right. Toxic, you got it. You got it. I don't know why you dictated the answer, but You were right. Your answer was what? Right. So you got it. So let's do it together. So solution, for example 1, we have 0.00450. So the first rule says all zeros starting the numbers should be ignored. All zeros at the beginning should be ignored. All zeros, so from here like this to here will be ignored. From here to here will be ignored. So we start counting from here. 1, 2. And another law says all zero after the decimal point should not be ignored. So this 0 is after the decimal point. So we'll count it as 1, 2, 3. So this will be what? 3 significant what? Figures. Then for the next question, we have 3.786 to 3 significant figures. So if we are counting from left to right, we have 1, 2, 3. We've gotten 3 significant figures, right? Okay, Doc said is equal to 3 significant figures. This is equals to 3.79, and this is equals to beautiful, beautiful, beautiful. So Toxic is right. He got the answers correctly. The 3 of them, he got it correctly. That is very, very beautiful. That is very, very, very beautiful. Yes, yes, yes. That is beautiful. He got everything correct. Everything correct. He got the 3 of them correct. That is wonderful. He got them correct. So this now will be what? 3.79, because you round this up. You round this 6 up to become 9, because it's greater than 5, right? So round it up. So this is in 3 significant figures. And finally, the last one is what? 4500. To standard form will be what? 4.5 times 10 raised to the power 1, 2, 3. So times 10 raised to the power what? 3. So Toxic, you're correct. A round of applause for Toxic. A round of applause for Toxic. A round of applause for Toxic. He's correct, 100%. So we've come to the end of today's class for the topic units, measurements and units. So this is the very first topic in JAMB Physics. The very first topic in what? JAMB Physics. From the JAMB Physics syllabus. So we're preparing for the next class. In case you're not on our JAMB WhatsApp community, please let me know. My phone number is on the thumbnail, on the flyer. Please let me know. DM me, send me a message so I can add you to the WhatsApp community. And please invite your friends to the next class. We normally have 2 sections. The first section is on WhatsApp, and the next section is on YouTube. So we're going like that for physics, chemistry, math, and biology. So before your JAMB 2026, you should be ready. So this is for JAMB. Thank you for staying to the end of today's class. A very big thank you. We love you so much. And this year, you will get nothing less than a 280 plus in JAMB. Yes, you're going to get your dream university, your dream course, and for those of you that mentioned your dream cars, you're also going to get your dream cars. So thank you for staying to the end of this class. If you enjoyed this class, please let me know in the comment section. Write, I enjoyed this class. let me know that you enjoyed this class. If you enjoyed this class, let me know in the comment section. Just type I enjoyed today's class in the comment section. Please let me know in the comment section if you enjoyed today's class. Write I enjoyed today's class. Thank you very much. We love you so much. You can stay with us for our 3 hours stream, which will continue. But this is the end of today's JAMB Physics class. Thank you so much for staying with us till the end. Let us know if you enjoyed today's class. If you have any other question, you can also, oh, thank you so much, Tribe Toxic. I had a nice time. You can also, please, you can also, thank you for staying with us. For those of you that are new, please watch the video because the video will be saved on the channel. You can watch it in case you're just joining us now. You can watch what was going on so you can be part of us. We'll be taking you on JAMB 2026 Physics, the complete physics script from A to Z. Yes, today has been an exciting class. As you can see, the chat section has been active, student has been participating, it has been an interactive section. I'm very happy about that. So tomorrow will be better, tomorrow will be better, tomorrow will be better. So come ready, come prepared. Feel free to ask questions, feel free to communicate. Thank you for staying to the end. Thank you, Confidence Precious. Thank you so much. Thank you so much. Thank you so much for staying to the end. Thank you so much. Really appreciate your commitment to your success. Yes, this class was for 2 hours, 38 minutes. Wow, and you stayed to the end. That is a step into your desired course. And this is how you get 280 in JAMB. This is the energy you use to get 280 in JAMB. And I assure you that if you keep on showing up, JAMB this year will be a piece of cake for you. You're going to eat JAMB this year. Yes, this year JAMB is going to be very interesting for you. You're going to enjoy every moment, every single moment of our classes because it's going to be a fun section. Yes, and by the end of all our classes, we'll have a quick test to test you on what you've learned so far. And yes, trust me, I'll be giving out prizes to our students at the end of our semester, at the end of the syllabus. Yes. Please invite others to join us and share this link to everybody you know that is writing JAMB. I'll also share it on the WhatsApp community. Bye for now and see you in our next section. Thank you. Bye. See you in our next section. Please make sure you like, share, and subscribe to our YouTube channel. In case you're new to this channel, make sure you like, share, and subscribe. Thank you for watching.